Hi.
Hello. Don't mind Miss Young, she's falling off her chair. So, today we are talking about curve fitting with quadratic models. So our essential question is, how do I use quadratic functions to analyze and predict data?
Yes, and we're going to recall something. We're going to recall that you can use differences to analyze patterns in data. So for a set of ordered pairs, it should say, with equally spaced x values, that's so important.
So here is a -1. Oh no.
They're all going up by 1, right?
Yep. Here we get +1.
That's what equally
Here is
spaced
+1.
means.
Got
They're
it.
all going up or down by the same amount. Then a quadratic function has constant, non-zero second differences.
So here's our first difference.
Yeah.
Which they're all different. But then our second difference
Are constant. So the word
Excuse me.
constant means
Same.
the same. So that's what we're going to talk about today. So if we scroll down, I think it's all it's showing you is for this
Is the
set of
graph.
data.
Yep.
Let's graph it. Okay, let's go to the next page. Determine whether the data set, so here's the question that we're getting at, so you understand
Yes.
what we're even trying to do here. You are going to determine whether the data set could represent a quadratic function or not.
Okay.
So step number 1, you have to look at your x values. Notice I wrote steps.
Yep.
Are the x values equally spaced?
Here I'm going up by 2, here I'm going up by 2,
And up by 2.
and 2.
So the answer is yes. So should we write that? Yes, they're equally spaced. Let's find the first differences now.
All right, so I am adding 2, I'm adding 6,
Correct.
I'm adding 10, and I am adding
14.
Thank you.
So we don't care about
No.
that. But the first differences, should we write them down there? Just so they know that's what we
Sure.
found. 2,
6,
6, 10, and 14. Now the second difference we could find that right from down here or
We
there.
could. I'm
All
going
right,
to do it here.
That's fine.
Just to stay.
I like
so I'm
that
adding
too.
4.
Adding 4 and adding 4.
So,
And-
yes, I'll just do it here too. So we see that we added 4
Each time.
for our
And
first difference to get our second
because our
difference.
second differences are constant, yes, we have a quadratic function. So the answer is yes, quadratic function.
Quadratic. There we go.
Function.
Function.
There we go. Good enough. Let's do another one.
All right, let's.
Here we go. Let's always look at the x's.
All right, going up by 1.
Going up by 1,
1,
and 1.
Okay.
Now let's look at our first differences. And notice we look at the first differences in the y values.
Yes.
So that goes up by
2,
2, that goes up by
6,
6, that goes up by 18,
Thank you.
and 54.
Oh boy.
So should we write that down there next to first
Sure.
differences? 2, 16.
6.
I love.
Okay. 18 and 54.
Good job. Okay, should I scroll down just a little bit for you here?
Sure.
Second differences. We're going
4.
up by 4. We're going up by
12.
12, and we're going up
A
by
lot.
36.
Those are not the same. They're not constant.
So therefore, it's not a
quadratic.
quadratic function. That's all we're doing.
Well, that's easy enough.
Pretty darn easy. I think we should do another one because this
Yeah,
video is
let's.
really short. So now, look at this.
All right. We're
The
going
x's
down
are going
by 1,
down.
which is fine.
That's fine. They're
as
still
long as they're
equally
down by the
spaced.
same amount.
Now let's look at our first differences in our y's. We're going up by 2, we're going up by 2, we're going up by 2, and we're going up by 2. Can we write that next to
2,
it?
2, 2, 2.
What are the second differences?
Well, 0, 0, and 0.
Okay, now guess what students want to do right now?
They want to say, it's a function.
They
Zero's
want-
all the same.
They want to say it's a quadratic function.
Right, that's right.
But guess what? It is not. It is not a quadratic function. It is actually a linear function. And this is why. Whenever your first differences are constant, it's linear. In all the other examples, the first differences were not
Different.
constant. So that you have to look at.
So
Right.
here's our answer.
It's not a quadratic function.
All right.
Next, we are now going to use our graphing calculators to write a quadratic function that fits a set of points. So we're going to go through this in class, so I'm
Yes.
going to actually skip it.
Perfect.
And And this example 4 and 5 go with the calculator. So we're
skip
skipping
it.
it. Let's see what this is. A quadratic model is a quadratic function that represents a real data set. Models are useful for making estimates. Now, if you recall, chapter 2,
Yes.
if you remember, we used our graphing calculators and we found our R value, which was
Right.
our correlation coefficient.
So those were wherever our dots were on the point, if
How
they were
closely
close
they were
together
related.
or apart.
Yep.
Okay.
And you wanted your R value really close to 1 or negative 1.
Yes. Yep.
And we found an A and a B, and we wrote remember, a line of best fit.
Yes.
We're kind of doing a similar thing here, but it's called, instead of linear regression, it's called,
Quadratic regression.
right, because we're dealing with a quadratic function.
So the U.
So instead of a correlation coefficient, we will be using a coefficient of determination, which is called R squared.
All right.
And what that does is that shows how well a quadratic function model fits the data.
Okay.
You want it close to 1 in this case. It's never going to be close to negative 1 because it's an R squared.
Right.
Here's a word problem. We are not going to do the word problem because it says use a graphing calculator.
We're
And
gonna
that
do
we
it in
have to do
class.
in class. And there we go. Which data set represents a quadratic function?
So look at your X's, make sure they're all the same. Then look for second
First-
differences.
Look at the first difference is
and then
first,
second.
and then the second.
Right.
And then the next question. What do you like and or dislike about flipped classroom learning? And please be honest.
Yeah, you won't hurt our feelings.
No,
We're
we just want to
curious.
know, do you like it, do you not, why or why not?
All
And
right.
that is it for
See you
today.
tomorrow.
Goodbye.